Welcome everyone. In this session, we are going to learn how to use Python and PSS to perform assessment of hosting capacity. Whatever you have learned in the previous sessions, we are going to put it into test in this particular session. So for this purpose, we have selected IEEE 33 bus distribution system. So this is my particular distribution system, which has 1, 2, 3, 4, 5 feeders or 4 feeders, and some load is connected at equivalent distance. So what we are going to do is we are going to assess how much renewable we can attach to this particular system. So let us discuss the methodology, the approach which we can follow. Bear in mind, this is one of the approach. You can use different kind of approaches. So the idea here is to give you an idea, and then you can build on that idea or use your own ideas to create something similar. So in this case, what we have to do is, so what basically will be a hosting capacity? Hosting capacity will be how much renewable we can attach at each node in such a way that the voltages on each of the section, on each of these nodes, each of these sections, and the flow through each of this feeder section should not be violated. So now here violation, how much violation do you want, or what kind of parameters you want to check, that is totally in your hand, because you are going to monitor these elements, and based on the monitoring of this, when any one of this indicator or KPI goes beyond a certain value, you are going to say that fine, so this is my limit. I cannot attach more a PV or wind or distributed generation into this particular system, because my one of my indicator, one of my quantity, one of my parameter has been violated. So the methodology we are going to follow here is something like this. What we are going to do is we are going to attach distributed generation as a negative load, because we just want to figure out how much generation is possible without going into the details of how much reactive power we are going to get, because we are doing some basic analysis to figure out how much. You can build on the code, you can create your own code which is more smarter, has more features, but here the idea is just to give you an initial technique. So what we are going to do is we are going to randomly select a node or a section, and on that particular node we are going to attach some negative load. We are going to run the load flow, and then we are going to monitor all the branches. So in this particular script, I am just going to monitor the branches and leave to monitor the bus voltages on you, so that you can build on this code and run it yourself and make changes to it to get more out of this code. And what we're going to do is we are going to monitor the flow on each and every section within this system, and once any one of the section gets overloaded, we are going to stop our simulation there. So we will attach on a load on a random load distributed generation on a random node, run, identify if there is any overloading. If there is no overloading, we are going to randomly select another node, do the same thing, run the load flow, again monitor, then select another random, and continue to select random generation, random DER generation and random node until we reach overloading on some section. So I've created this code for you, and then we are going to go through this code, try to understand what are the different building blocks of this code, so that you can you can write a similar code for yourself and perform hosting capacity assessment or something like this. So the first building block of this script is the violation code. We need to identify the violations. So how we can identify the violation? What we have done here is, first of all, we are going to take some case, and we are going to solve that case. So just to make sure that the case is solved properly, I have used here this load flow analysis for performed it 3 times. So you can perform it 1 time, 2 times. It depends upon you how weak your network is, how strong your network is, how your network behaves. So based on the performance of your network, you have to change the selections, the options, and everything. So it is going to change from network to network. Then we are making sure the case is solved. So we are making sure here, if the case is solved, only then perform the monitoring purpose. So if the case is not solved properly, I'm not doing anything. In your case, you can write some code to find out other ways of solving this particular case, and finding out the solution, or breaking out of the code, whatever you want to do. So here the idea is to just explain you the basic architecture. And then what we have got as an input in this particular function is the branch list. So what I'm getting is the branch list, and then I am iterating through this branch list and getting the MVA loading of that particular line, rate A of that particular line, and finding out the percentage. Within PSSC there is a API which gives you direct percentage. So if you want to do that, you can use that as well. But here what I'm doing is I am just converting that MVA loading to percentage based on its rate A, and then saving it as a 2 decimal variable. And then I'm checking if my MVA value is greater than rate A, or my percentage value is greater than 100% or 105% or 120%. Now this is where your parameter and criteria comes in. What is your criteria? So your load should not exceed 120%, your flow should not exceed 150%, your flow should not exceed 80%. So these kind of things are totally on you. So I'm checking if it is greater than this value for any bus, any particular bus out of this. So as soon as the first violation is reached, what you do is you make the violation flag true. Yes, I have a violation. And then what kind of violation I have? I have a line overloading. In the same way, you can create a separate loop for transformer loading. You can create a separate loop for voltage violation. So here I have a line loading problem. Which line is loaded? So I am giving the name of that particular line, or the indication identification of that particular line, and I'm showing how much it is overloaded. Else return none. So in this case there is no violation, no values to be written, and return. So every time this function is going to be called, it is going to check all the lines, and if it gets a violation, it is going to return the true flag, or flag for that violation has occurred. Otherwise it is going to return no violation has occurred. In the same way, as we said that we have to choose bus randomly. So here we are choosing a random bus. So out of the bus list which we will define in our main function, so we take the list as an input, and out of this input list we randomly select one bus, and on that one bus what we are going to do is we are going to connect our load, this DR load, or the DR generation. So now how much generation do we need to attach? This is given in another function which is known as get plant size under megawatt. So what this function is basically returning based on a normal distribution. So we are assuming that because it's a distribution system, it has very less values. So its total capacity of this distribution system is something around 9 or 10 MVA based on the rate A of each and every. So it's a very small system. So what basically we are trying to say here is that in this particular case, what you need to do is the maximum generation which you can have, what is the mean of your generation, and how much on either side it can go. So here I am selecting 1 megawatt as the mean, and on the distribution can go 0.5 3 sigma. So this is basically sigma, the standard deviation. So the standard deviation can go 0.5 on either side. right? So based on this, it is going to select one random variable within this distribution and return this back this value. And what we are going to do is we are going to use this value on this particular node and perform the load flow and monitor here. And then we have load network. So each time the iteration is done, I need to reset the case and get the new case again and rerun all these calculations. So that's why we have created another separate function, which is the load network, which is going to load my PSS. We could have done that in the original case as well, or in the main as well, but we have created a separate function so that if you want to build on this function, you need to add additional features. You can add additional features. Now coming on to the main program. Within the main program, we are calling our OS and sys and NumPy library. Why we are calling NumPy library? Because we are using this NumPy library to get the random values. Similarly, pandas, we are getting this pandas library because we are going to add all this information into pandas data frame and then export it in the form of a Excel sheet or a CSV file. Similarly, somewhere we need to load these values back because and then create a case which is my most probable case or the best possible combination of DER which can be connected to this. So that's why. Similarly, iteration tools, permutations. So if you want to further do something, I mean, you now you have all the values. So if you want to change the locations and you want to try different combinations of that particular generation, so you can do that. For that purpose, you will need permutation, but we are not using this in this particular script which we are discussing right now. Then here we have called PSSE, and these we have already discussed these things, so I will not go through the details of this. Then moving on, we have defined folder, we have defined the case which we want to perform. Then we have defined a separate case which is basically a case built on this case. Now the original case which you have seen contains all the loads and everything. Now we need to add a negative load. It can be done in two different ways. If you are using version 35, within version 35 there is a separate section within the load where you can add DER generation. But if you are using version 33, in that case you do not have. So now you have two ways to do it. Either you create a mechanism where you subtract your load from this generation and build on it, or what you can do is you can simply create new negative loads on each node and then add the generation, add this new generation into it. So this is what I have done. So I've taken the original case. Within the original case, I have seen which are my probable RES nodes on which I need to check this new generation. And on all these nodes, I have created a new load, which will be my which will be considered as my DER generation, PV generation, RES generation. And on that particular load, what I'm going to do is I'm going to add this new generation values. And then once everything is done, I am happy with my solution, and then I'm going to save the final case in this form, new save file. And the results of the assessment are going to be stored in assessment underscore results. So this is basically where, as I told you, we are going to do multiple iterations, and for each iteration, what was the violation and where did the case stop? So this I'm going to store in a file, Excel file known as assessment underscore result. Then I open my case, and here what I'm doing is I am selecting the bus system or the feeder system where I need to perform, which I need to consider. So you can do it. I mean, if you are planning to select all the branches. So here basically I am selecting a case, a section of the case. In my case, the selection of the case is the whole system except my utility bus, which is the end bus, which is bus number 1, which you see here. So except this bus, consider all the branches. Similarly, consider all the nodes, all these buses for RES generation except this utility bus, except this bus. So this is what I am trying to do here. So what we will do is, so I took all the buses and I got the all the branch from bus to bus ID and converted into a branch. And in the same way, I selected all the buses. I figured out how many buses are there, and then how many RES nodes are going to be there except my utility bus. All the rest are my probable RES nodes. So what I have done here is I am iterating through the list and I am checking the code of each list, because my utility bus where the utility I have made an equivalent of the utility, that is basically my swing bus. So basically what we are trying to say here is that if you figure out a utility bus in your system or you figure out a swing bus in your system, please do not consider that as a RES node. So all the swing buses are not going to be considered. Apart from that, every bus in your system is going to be considered. So this is exactly what it is doing here. And then once you figure out this is your probable RES node, or this is not a utility bus, or this is not a swing bus, what we are doing is, as I explained you, we are going to add an extra load, and this load we are going to call it PV, and all the RES generation which we are going to predict from this code is going to be added as a negative load in this load. So we are not trying to play with the original loads which were connected in the model. So we created our own extra load, and whatever we are trying to do is we are trying to do in the this load. And then once we connect a load, we solve the case. This is how it is done. And once everything is done, so what we are going to do is we are going to save this file as a new file, which we explained in the above, that host underscore save file. Then we are going to close this power flow case. So everything is done. So the next thing we are doing is we are creating an iterative. So we want to perform iteration for 50 times. So I have set the counter, iteration counter, for 50. You can do it for 10 times, you can do it for 100 times, you can do it for 1000 times. So that is totally upon you. And then I'm going to store the results of the assessment in a data frame, and that data frame should contain the columns as installed, the violation, the branch, because I am getting the branch violation. If you are having multiple violations, so instead of branch you can use equipment type. So that equipment type can be bus, transformer, transmission line. So here, because I only am selecting one thing, that, and the percentage loading, and then you can violation parameter or whatever you want to write. So here, because it is branch, so the only thing related to branch is the loading. So I am getting this. Then I am getting two empty lists. One is for the location, the random location for that particular iteration, and the random size on that location for that particular iteration is going to be saved in these lists. And this is my whole thing where the original, this is the brain of the entire operation. So here what we are doing is starting the counter. Starting from 0, we will go all the way to 49, which means 50 iterations. So we are going to load the network. We are going to load the fresh network. In this case, we are going to load the network in which we have made the changes. We have added additional load which are going to serve as renewable generation, right? So we are going to do this. Then install the initial added renewable or distributed generation in this particular system is 0, right? So we adjust the set the counter at 0, and now while the value remains 1, you do this. So basically it's kind of an infinite loop. I am going to remain in this loop until I get a violation for first iteration. As soon as I'm going to get violation, I'm using the break. So this break means I'm going to come out of this loop and going to go back to the counter for the next time. So that's why this while one is there. And what I'm getting is, get me the violation type, the circuit, and the loading. All right. So these were this was my the function, and what I need to provide into this function, branch. So now what is going to do is, it is going to take this case and it is going to go here, and it is going to check all the branches. If there is no violation, it is going to return none, and then it is going to come here. So if if violation is there, if the violation is true, yeah, so let's see if there is no, because first time the first time it checks, it is going to return false, means there is no violation. Then it is going to come to the else side, right? So it comes to the else side, select underscore best. So what we are going to choose is randomly choose a location, randomly choose the value, and I am making sure the value is always a positive value, because this random we are using this 3 sigma 2 plus 3 sigma, so we can end up with a minus value as well sometimes as a random value of the megawatt. So making sure that every time I get the value is a positive value, right? So I use absolute. So get plant size, so random plant size, random node comes here. So the negative load, which I created a new load as PV, so the random selected bus, and the random load as a negative generation, because we want to consider it as a generation rather than a load. So we are going to update these values, and we are going to add this into, so instead of 0, this is going to become 0 plus this size, and every time new generation value is going to come, it is going to get added here, so that at the end I get the final value of my total hosting capacity. And then save the location and save the plot size for that location into these. So it continues to run until a violation comes. So once the violation comes, what is going to happen? It is going to write the results into a row. So it is going to take the first row and going to write what it is going to write. It is going to write the installed megawatt, the violation type, the circuit which is getting overloaded, and how much it is getting overloaded, right? And then I am creating a CSV file and creating a new data frame, and within that data frame I am saving the location and the sizes, so that I can once this simulation has ended, the script has run, I will have multiple files and I will see which is the best combination, and then I can open that particular CSV file of that combination and say, okay, fine, within this these are the renewable generation we considered, and then we can build on that case later. And then I'm going to save these values into a CSV file and then reset these location and the size for the next iteration, and then break the code. So this is how the code is going to work. Once it comes out of the code, all the 50 iterations have been performed. I'm going to write the results into Excel with index is equal to false. So just write the values, do not write the index with it. We already went through this. Similarly, now I am going to filter. So now what I'm going to ask the script to do is, please figure out all those loading conditions where you have a loading between 100 and 110%, 101%. So basically I am trying to figure out, because if the loading is more than this, it means that that particular set of calculation is not valid, because that particular set of hosting capacity is going to give me very high overloading. So I want to select only those cases where the overloading is within a reasonable range. So I select this. You can increase or decrease this. So I select this, and out of this give me the largest possible value, so I get the maximum installed capacity out of it. So once I get this installed capacity, I'm printing the index of this is just to see, and then the hosting capacity will be the installed capacity which I get for that particular value, right? And then what I'm doing next is I am going to store I am going to get the CSV file of that particular instance. So that's why what I did here is this index. I printed this index. So I want to know, because the CSV file name is exactly the same as the index. So what I'm doing is read that particular index CSV file, and then within that file open the original file with 000 distribute this DER negative loads which we created, the original file, and then go to each. So what I'm doing is iterate through each index, and within each index whatever is the bus location, go to that bus location and update the DER. So what we did was we filter out the best possible combination of DER, which will be one combination which has overloading between 100 and 101%. And for that particular loading, what was my values? Random buses selected, and within that random bus, how much the distributed generation was selected. So I'm going to load them, solve the case, and save it as a new case, which I'll simply go here and press run. We have already discussed all these things. So once the case is run, what you are going to see is, if you go to the original path where you saved, so you are going to see all these CSV files created. In the same way, you are going to see this bus assessment created. So if I double click on this, let's open this up, and what you see here is this: the installed capacity, the overloading type, and the overloading we have. And out of this, which one is my best one? So we can see from here the largest index, so that is 36. So what I simply need to do is I need to go here and open this 36 CSV file. So once I open this, so if I can auto sum this one, you see 21.61 is more or less the hosting capacity. And in the same way, if you go here, you're going to see this new file created. So just open this file, and in this file you are going to see that your case, all the renewable generation is already added, everything, because we were only considering one parameter, which was line loading. We were not considering this voltage violation. So maybe you are going to see some voltage violation